Let's take a look at some profile limits and drive limits in RandomView, one of our software modules in VibrationVIEW. So while I have this random test open, I'm going to edit my test. You see I'm in my advanced test settings. And I have my tolerance and abort lines mirrored to match this graph here. So as I change these values, my graph will adjust appropriately. So I can set this checkbox to use the same tolerance and aborts on all levels. So as I insert more steps, I get the same values here. Or if I need different tolerances and aborts at different locations, I can adjust them here. So maybe on this section of my test, I need wider aborts. This one, maybe I need tighter tolerances here and here. And now you see that my abort and my tolerance lines break up into these sections. One thing to note here is that you just need to use the whole number in the positive and negative sections. Do not put -6 because that will equal +6. So just use the whole number. No need to use the positive or negative. We've already done that in the software. So I can also choose to use channel tolerances. So I have the ability to average control or use multiple channels for control. So what I can do is when I click the choose the channel tolerances, instead of using my average control, let's say I've chosen average control of 2 channels, instead of using that as my tolerance, it will use each individual channel as my tolerance. Moving over to the limits tab here, this is a continuation of my tables tab. So this is telling me that I'm using the table tolerances and aborts. If for some reason I did not want to use those any longer, I would uncheck that box and now I would get a uniform tolerance and abort set on based on what I've set here. The max outliers is enabled whether or not I'm using limits tab from my table or if I'm using my limits here. My max outliers is the number of spectral lines that are allowed out of tolerance, and I can use I can use lines or percentage for max outliers. If I were to turn on my individual channel tolerance RMS, I would want to click this box. This is enabling the individual RMS aborts and tolerances for multiple control channels. Otherwise, this is giving me my RMS aborts and tolerances based on my full RMS signal. The spectrum limits are giving me my tolerance and aborts based on the in-band spectral content. Another section to look at for limits is our drive limits. This section here is our drive limits. We have startup limits and we have running limits. In random, there is one place to put your max output voltage. Typically, the controller only puts out a maximum of 12 volts. So approximately 4 RMS would be the highest number you would want to put here. But we want to always keep this number as small as possible to run my profile. If I use large numbers here, the output of the controller has the potential to change more drastically than maybe I want. So system gain is a volt per G ratio. My output threshold is how much drive output is required to move my shaker and how high step up those drive outputs. What's the value that I output as I'm ramping up. If I get to 20% of my maximum output and I'm not at 20% of my demand, then the software is going to stop and warn you. You can choose to continue, and if that continues on and I get to 50%, we're going to abort the test. So a nice picture, we can easily see the profile limits picture here. My red line is aborts, my dotted line are my tolerances. But a good picture for this plot here is our drive versus input graph. So that graph I have visible to my left here. So I'll run the test. I'll start over. So my demand is this green arrow, and my control and my channel 1 should be ramping up to meet my green arrow. So I got a max Excel reading on my individual channel. So I'm going to turn off my averaging so I can give a good demonstration of the drive versus output. Back to limits. As you can see, my red line here is my volts per G ratio in relationship to my maximum output. My maximum output here is 1 volt RMS, and we can see this line slope based on these settings here. So I'm going to put a gain of 25 volts per G and hit apply. You can see this second line moved to show my volts per G gain of my startup voltage. And if I adjust my running volts per G and hit apply, you'll see that that other line moved up. So as I put a higher number in my volts per G, the slope of this line gets put higher in ratio to my maximum output. So I can get a nice visual of using my gain settings by clicking on different gain settings and watching my threshold limits lines change. And if I were to put this gain down far enough and I saw my control channel hitting this red line, then I would get a max startup gain voltage error. And if I were adjusting my settings, I would want to raise this gain value up just high enough to where I pass these startup values. So my drive versus input plot gives me a lot of data to let me know where I should set my drive output limits on my limits tab.